China just shocked the world with what they're building. But here's what no one is talking about. While Western media keeps you distracted, China is quietly racing ahead, creating a future straight out of science fiction. AI that thinks for itself. Machines that replace humans. Cities run entirely by algorithms. AI in healthcare. In 2024, the United Nations Population Prospects released a sobering forecast. China's population, once thought immovable at 1.4 billion, is expected to decline to 1.3 billion by the year 2050, before falling even further to just 633 million by the end of the century. The report warned that between 2024 and 2054 alone, China will experience the largest absolute population loss of any nation on Earth. This decline did not emerge overnight. It is the result of decades of compounding pressures, from the long-term effects of the one-child policy to rising living costs.
If you lived in a Chinese city, and that's now the majority of Chinese people, you could only have one child. If you lived in the countryside, you might be allowed a second if your first was a girl.
And a job market that leaves younger generations uncertain about their future. For many women, the anxiety runs deeper still, shaped by concerns over access to adequate care during pregnancy and childbirth. Faced with these realities, an increasing number are choosing not to have children at all. The consequences extend far beyond falling birth rates. A shrinking population means fewer workers, fewer caregivers, and fewer doctors, arriving at precisely the moment an aging society will require more medical support than ever before. The growing imbalance between healthcare demand and the number of available professionals has long seemed like an unsolvable equation. Yet, just as the pressure reaches a breaking point, a different solution begins to take shape. In 2025, as China concluded its 14th five-year plan, the government revealed a response that few outside the country had anticipated. Confronted with a widening gap between population needs and medical capacity, China unveiled something unprecedented: its first artificial intelligence-powered hospital. Known as the Agent Hospital, this initiative is not a physical building of wards and corridors, but a vast virtual healthcare ecosystem. Developed by researchers at Tsinghua University's Institute for AI Industry Research, it was first introduced in a research paper published in May of 2024. Its core purpose is bold: to train artificial intelligence doctors at a speed and scale no traditional medical institution could ever achieve. Within this simulated environment, powered by a self-learning framework called MedAgent Zero, AI agents take on the roles of patients, doctors, and nurses. These agents interact continuously across more than 300 diseases, enabling AI doctors to practice diagnosis and treatment autonomously. Through constant repetition and feedback, they learn in days what would take human doctors years to encounter. What began as a research experiment quickly moved beyond the laboratory. A Tsinghua University spin-off company, Tyrex, is now commercializing the project. In April of 2025, it entered its first real-world pilot at Beijing Tsinghua Changgung Hospital. For the first time, the Agent Hospital system was integrated directly into a functioning medical institution, marking a decisive shift from theory to practice. The pilot was introduced in phases, targeting departments where efficiency gains and diagnostic support could have the greatest impact. These included general practice, ophthalmology, radiological diagnostics, and respiratory medicine. Importantly, the AI doctors are not designed to replace human physicians. Instead, they work alongside them, streamlining workflows and offering real-time diagnostic and treatment recommendations, easing the burden on overstretched medical staff. During testing, the system processed 10,000 patient cases in just a few days, achieving a reported diagnostic accuracy of 93%. Handling a comparable volume of cases would take human doctors years. The pilot currently involves 42 AI doctors across 21 medical specialties, collectively capable of managing more than 300 diseases. Yet patient care represents only part of the vision. The Agent Hospital also serves as a training ground for the future of medicine itself. Medical students can learn in this environment, developing the skills needed to collaborate with, rather than compete against, artificial intelligence. Over time, this model aims to address deeper structural challenges, from physician shortages to unequal access to quality healthcare, particularly in rural and underserved regions. This strategy extends beyond virtual hospitals alone. China is also investing heavily in non-invasive health monitoring technologies tailored to an aging population. One recent study describes an AI system that combines acoustic and visual analysis to detect sleep disorders such as apnea by monitoring facial expressions and audio signals. The system achieved a clinical agreement rate of 94.6%, with an average detection delay of just 10.7 seconds, showing that early intervention could be faster and more accessible. But if machines can diagnose disease faster than humans, what happens when they begin watching us too closely? The AI Peacekeeper. In July of 2025, Chinese public security officials stepped before cameras with a striking claim. Despite rapid urbanization and profound social change, China now records one of the lowest homicide rates in the world. In 2024, the figure stood at just 0.44 deaths per 100,000 people. Over the course of the 14th five-year plan, authorities reported dismantling more than 590 mafia-style organizations and nearly 9,000 other criminal gangs, resolving over 105,000 related cases. Among all criminal threats, telecom fraud stood out most clearly. During the same period, police shut down more than 1.7 million scam cases, arrested 366,000 suspects, and blocked billions of fraudulent calls and messages. Officials stressed that these results were not accidental. They were the product of a public security system increasingly built around artificial intelligence. At the center of this system is a vast and expanding network of cameras and sensors. Often referred to simply as Skynet, it is in fact a collection of interconnected programs. One focuses on major cities and uses high-precision facial recognition. Another extends into towns and villages, even linking some household cameras into shared security networks. Together, they form a surveillance web that spans crowded urban streets and remote rural roads alike. The scale of this expansion is hard to ignore. China now operates nearly 800 smart city pilot programs and has become the world's largest investor in video surveillance.
We can pass in the vehicles and tell what type of vehicles it is, and also it could detect the bicyclist, motorcyclist, and even recover their trajectory.
In 2023 alone, spending surpassed $38 billion. Increasingly, these cameras are powered by AI, allowing them to do far more than passively record footage. What truly defines this system, however, is how it is used. Law enforcement no longer waits for crimes to occur. In Kunshan, a city in Jiangsu province, the Kunpeng AI police team demonstrates how predictive policing has taken shape. Drawing on more than a decade of historical data, the team developed over 220 AI models designed to disrupt crime and intercept scams before damage is done. In one case, the system froze a fraudulent transfer of 500,000 yuan in under 10 minutes, traced 87 linked accounts, and supported arrests within 3 days. Officers estimated that the same investigation would typically require 5 or 6 people working for 2 whole weeks. Instead of reacting late, the system moved first. This speed also enables law enforcement to look ahead. Large AI models now analyze past crimes, travel flows, and crowd movements to forecast risk. Ahead of major holidays, systems may warn that theft or fraud risks are rising in busy commercial districts, allowing police to adjust patrols before incidents occur. In some regions, including Xinjiang, AI systems automatically flag behavioral patterns deemed high risk and send alerts directly to officers. Decisions once mainly driven by intuition are increasingly guided by data. The influence of AI extends beyond policing and into the justice system itself. Prosecutors now rely on AI tools to review case files, cross-check evidence, and assist with drafting legal documents. Some systems can even identify potential weaknesses in a case before it reaches court. Inside courtrooms, judges use AI to organize evidence, compare similar rulings, and suggest sentencing ranges. The gains in efficiency are substantial. At the Hainan High People's Court, officials reported that AI tools reduced the time required to draft judgments by 70%. Under the National Smart Courts Plan, every court is expected to use AI systems by the end of 2025, with full nationwide integration targeted by 2030. In everyday public spaces such as airports and railway stations, AI-driven surveillance now handles continuous monitoring. Rather than staring at screens for hours, officers respond when systems trigger alerts. Their role shifts toward decision-making, communication, and on-the-ground response. This allows fewer personnel to secure much larger areas, easing pressure on a workforce already strained by demographic decline. Yet this expanding reach also raises serious concerns, particularly around privacy and data protection. In response, new regulations began taking effect in 2025. Companies using facial recognition are now required to obtain explicit consent and provide alternative identity verification options in commercial settings. Organizations handling large volumes of personal data must conduct regular compliance audits, while authorities have launched enforcement campaigns against apps that misuse data or abuse AI tools. These measures do not halt the system's expansion, but they aim to draw boundaries around it. As AI increasingly predicts crime, guides patrols, and shapes justice, how much control should we be willing to give them over the systems that move us through the world? Guardians on the road. In December of 2025, China crossed a major regulatory threshold. The Ministry of Industry and Information Technology granted the country's first production permits for conditionally autonomous Level 3 vehicles.
The ride is a little bit juddery. The motion sensors are so sensitive they'll stop for anything that could be a possible obstruction.
For the first time, self-driving cars were legally approved for limited use on public roads. Two models received authorization: the Chang'an Shenlin SC and the ArcFox Alpha. The approval came with strict limits, reflecting a cautious, safety-first rollout. The Chang'an model is allowed to activate its automated driving system only on designated highways and urban expressways in Chongqing, only during traffic congestion, and only at speeds below 50 kilometers per hour. The ArcFox model is approved for selected highways in Beijing with a higher speed limit of up to 80 kilometers per hour. In both cases, the vehicles will initially operate under close supervision, similar to robotaxi trials, with professional fleet operators and safety monitors on board. The goal is to collect real-world data while maintaining human oversight. This step is a state-backed effort to reduce traffic accidents, which are caused mainly by human error. As China's population ages and the number of younger drivers declines, road safety has become a growing public concern.
I received the first citywide permit to run robotaxi in Shenzhen. What does it actually mean? How soon do you think we will travel to Shenzhen and get a robotaxi?
Automation is being positioned as a tool to stabilize safety, not as a way to replace drivers overnight. Behind these approved models is a rapidly advancing vehicle intelligence stack. Many Chinese cars now integrate onboard AI systems that handle perception, decision-making, and driver interaction. Some vehicles include voice-based AI assistants that allow drivers to issue spoken commands, such as requesting that the car navigate to a location or reposition itself within a limited range. These systems rely on high-performance computing hardware, including dual AI processors, as well as dense sensor arrays comprising high-definition cameras, ultrasonic sensors, and multiple radar units. Together, they enable functions such as lane changes, obstacle avoidance, traffic light recognition, automated parking, and complex urban turns. At the same time, Chinese automakers have pushed vehicle mobility far beyond conventional driving. Models such as BYD's Yangwang U8 use 4 independent electric motors, allowing each wheel to move separately. This enables features like zero radius turns, sideways movement into parking spaces, and precise low-speed control in tight environments. The same platform allows limited water traversal, where the vehicle can float briefly and move at low speed through deep floodwater, offering an emergency escape option rather than a daily driving mode. Other manufacturers have focused on extreme maneuverability in dense cities. Vehicles like the IM Motors L6 use four-wheel steering and independent motors to reduce turning radius and allow horizontal parking movements. This design reduces the space required for parking and improves access in crowded urban areas. Similar systems appear in models like the BYD Z9 GT, which can slide laterally into narrow parking spaces using controlled wheel rotation.
This is here the Denza Z9 GT. We're going to explain you all about it. This high-tech vehicle with a lot of new technology features you've maybe not seen before, but how good is it for real?
High-performance electric platforms have also advanced rapidly. BYD's Yangwang U9 supercar demonstrates how software-controlled suspension and motor systems can deliver both speed and stability. Its suspension can lift individual wheels within milliseconds, allowing the car to adjust ride height, absorb uneven surfaces, and maintain control under extreme conditions. These systems are production-ready and sold commercially, not limited to concept vehicles. A broad national ecosystem supports all of this development. Technology firms such as Huawei provide full driving system architectures used by multiple automakers. Baidu's Apollo program operates one of the world's largest robotaxi fleets, with millions of completed rides in cities including Wuhan and Shenzhen. Autonomous driving companies like Pony.ai, WeRide, and Deeproot.ai focus on higher-level autonomy for both passenger transport and freight. At the consumer level, manufacturers such as BYD, XPeng, NEO, and Li Auto have made advanced driver assist systems standard across much of their lineup. As a result, more than half of all new cars sold in China now include Level 2 driver assistance features. This creates a constant flow of driving data and familiarizes the public with partial automation, easing the transition toward higher levels of autonomy. Crucially, China has also addressed legal responsibility. Under national rules, when a Level 4 or Level 5 vehicle is operating in self-driving mode, liability for accidents falls primarily on the manufacturer or fleet operator, not the passenger. This removes a major barrier to adoption by giving companies legal clarity and consumers clear protection. Rather than leaving responsibility undefined, the state has chosen to absorb and manage the risk. From self-driving cars to highways without drivers, the question is, who or what builds the roads of the future? Travel at the speed of light. The country is now developing a new generation of maglev trains designed to move at speeds once reserved for aircraft. At the center of this effort is the T-Flight project, a prototype maglev train built to reach speeds of up to 965 kilometers per hour. At that pace, the line between rail travel and air travel begins to disappear. Reaching such speeds requires overcoming fundamental physical limits. The first solution is magnetic levitation. Powerful electromagnetic forces lift the train roughly 10 millimeters above the track, eliminating wheel friction. With no physical contact, the train no longer loses energy to rolling resistance. But friction is only part of the problem. At extreme speed, air resistance becomes the main barrier. To address this, the T-Flight system is designed to operate inside a low-vacuum tube. By reducing air pressure inside the tube, engineers sharply cut drag, allowing the train to accelerate far beyond what is possible in open air. In February of 2024, these ideas moved from theory to proof. During a test run on a 2-kilometer track, the T-Flight prototype successfully levitated and accelerated to 623 kilometers per hour. The test confirmed that both the maglev system and the low-vacuum environment work as intended. The next step is far larger. Plans are now underway to build a 60-kilometer full-scale test line in Shanxi province with the stated goal of breaking the 1,000 kilometers per hour barrier. While this work pushes the limits of speed, China is also reinforcing its lead in conventional high-speed rail. In a major milestone, Chinese experts chaired the committee that set the global standard for high-speed railway infrastructure design. That standard, now used worldwide, reflects China's real-world engineering experience. It includes designs for earthquake-resistant bridges and ultra-stable slab track systems, effectively making Chinese practice the global reference point for safety and reliability. Building projects of this size would not be possible without changing how construction itself is done. This is where artificial intelligence and robotics move from support tools to core infrastructure. Across rail projects, automation is being used to build faster, reduce risk, and cut dependence on heavy manual labor. Companies such as MechMind Robotics are leading this shift. Their systems bring what is known as embodied intelligence onto construction and manufacturing sites. The process begins with the eye. High-precision three-dimensional cameras scan complex scenes using laser projection, creating detailed models of objects and surfaces. These systems can accurately read shiny metal, rough concrete, and even transparent materials. The data then moves to the brain, where an AI model processes what it sees. Unlike older robots that follow fixed scripts, this system can understand spoken instructions. A supervisor can give a simple command, and the AI plans how to complete the task step by step. Finally, the hand, composed of robotic arms and gripping tools, performs the physical work. On rail construction projects, this technology appears in several key areas. In manufacturing yards, AI-based inspection software performs 3D inspections of thousands of components, such as railcar frames and track switches. These inspections reach millimeter-level accuracy and catch tiny defects faster than human teams ever could. In logistics centers, autonomous robots sort, move, and load heavy and irregular materials, keeping supplies flowing to work sites exactly when needed. Robots are also taking over some of the most dangerous jobs. Tasks like welding in tight spaces or lifting steel beams at great heights are increasingly handled by machines instead of people. This improves safety while also speeding up construction schedules. If robots can construct bridges and lay tracks at impossible speeds, can they also ensure we never go hungry? The AI farmer. As China's population grows older and its rural workforce steadily shrinks, the question is no longer how to farm better, but how to farm at all with fewer hands each year. Villages are emptying, skilled farmers are aging out, and the risk is clear. If production falls behind demand, food security becomes a national vulnerability rather than an economic inconvenience. For years, this slow decline built quietly in the background. Fields still produced crops, but the human system behind them was thinning. Fewer young people returned to the land. Fewer workers were available for planting, spraying, and harvesting. The old model, built on labor and experience passed down over generations, was no longer sustainable. In response, the state moved decisively. Between 2024 and 2028, China launched the National Smart Agriculture Action Plan, placing farming squarely at the center of its long-term security strategy. Released by the Ministry of Agriculture and Rural Affairs, the plan formally commits the country to a digital transformation of food production. Artificial intelligence, big data, and connected sensors are no longer optional tools. They are the backbone of a new system designed to survive demographic decline. By 2028, the plan targets a digital integration rate of more than 32% across agricultural production, signaling a fundamental shift in how food is grown. This strategy unfolds through a layered technology system that replaces guesswork with data.
Precision farming is this idea of harnessing data, using lots of sensors of your specific fields, your crops, but also the environment around you, like weather data and things like that. Harnessing that to actually try and maximize your yield.
Low-cost soil sensors measure moisture and nutrients. Drones scan crops from above. Satellites track weather patterns and field conditions. All of this information flows into centralized platforms, often described as agricultural brains. There, AI systems analyze the data and issue clear instructions, removing the need for constant human oversight. For farmers like Wang Huan in Jiangsu province, this change is already real. Instead of walking his peach orchard row by row, Wang deploys drones equipped with advanced cameras. The AI scans the images for early signs of pests or disease. If a problem is detected, another drone is sent to spray only the affected area. The entire process takes about half an hour. By hand, the same work would take 5 hours. The difference is not convenience, it is survival. This precision extends to water and fertilizer. AI systems study soil data, plant growth, and weather forecasts to decide exactly when and where resources are needed. This method, known as variable rate application, avoids waste and raises yields. Nothing is applied blindly. Every input is targeted. As these systems mature, their reach expands. AI tools now predict crop yields months before harvest, helping planners prepare storage, transport, and pricing. After harvest, computer vision systems assess quality at speeds no human team can match. In one case, AI systems learned to judge the ripeness of durians with more than 90% accuracy, a task once based on experience and intuition alone. Produce is then automatically sorted by size and quality, eliminating hours of manual labor. Food, safety, and trust are also reshaped. In a pilot project, AI combined with blockchain traced a box of mangoes from farm to shelf in just over 2 seconds. Before, the same task could take nearly a week. In a complex national market, speed matters. The transformation does not stop with crops. In livestock farming, cameras monitor animal behavior, flagging early signs of illness without human inspection. At the edge of the system, AI is also shaping new food sources. Companies developing alternative proteins now rely on AI to guide fermentation processes and refine taste and texture. These tools shorten research timelines and reduce risk, turning long-term food security into an engineering problem rather than a gamble. However, this vision faces real obstacles. The first is cost. A complete drone and software setup can exceed 200,000 yuan, far beyond what most small farmers can afford. To solve this, a new model is spreading. Agriculture technology as a service allows farmers to rent access to AI tools instead of buying them outright. Drone spraying, satellite analysis, and data services are offered on demand, lowering the barrier to entry. The second challenge is people. In many villages, more than 70% of farmers are over 50 years old. Fewer than 5% can use farm apps on their own. Without training, the technology would sit unused. To prevent this, governments and companies have launched hands-on education programs. Courses teach farmers how to adjust pesticide levels, read AI reports, and use digital tools in daily work. The goal is adoption, not display. As these systems take hold, their impact reaches beyond yields. For younger people returning to rural areas, AI acts as a bridge. They may lack decades of experience, but data gives them a way to compete. Farming becomes manageable, predictable, and economically viable again. This shift supports broader rural revitalization efforts, in which villages are rebuilt around digital infrastructure. AI systems now assist local officials as well, helping manage records, analyze data, and run services more efficiently. There is also an environmental payoff. Research shows that AI-driven farming cuts fertilizer and pesticide use, areas where China once led the world in excess. Smart irrigation saves water. Emissions fall. These gains spread outward, as nearby regions adopt similar systems and benefit from shared progress. When drones tend the fields and harvest with precision, what else might these machines learn to do beyond human limits? The robotics revolution. The development of agile quadruped robots, commonly called robot dogs, has become one of the clearest demonstrations of China's push toward autonomous, rugged robotics. Leading the pack is Unitree Robotics, whose platforms are engineered for sustained operation in demanding real-world environments rather than controlled labs. The Unitree Go 2, for instance, integrates a sophisticated four-dimensional LiDAR system capable of 360 degrees by 90 degrees hemispherical recognition, with a minimum detection range of just 5 centimeters. This enables the robot to perceive and navigate dense, unstructured terrain autonomously. With a top speed of roughly 5 meters per second, the ability to climb 40-degree inclines, and a payload capacity of up to 12 kilograms, the Go-2 is built for endurance, mobility, and reliability. This physical design, low center of gravity, 4-point stability, and the ability to carry sensors or tools determine where these machines are most valuable. Quadruped robots excel in 3D roles, tasks that are dull, dirty, and dangerous. These are precisely the jobs that are becoming hardest to fill as China's workforce shrinks and ages. China maintains an enormous network of power plants, electrical substations, chemical facilities, pipelines, rail corridors, and logistics hubs, all of which require continuous inspection and preventative maintenance. Traditionally, large teams of skilled technicians performed these physically demanding and often hazardous tasks. As the working-age population contracts, sustaining this model is increasingly complex. Industrial-grade quadrupeds now bridge this gap, moving from experimental tools to structural solutions. The Unitree B2 is the perfect example of an industrial-grade quadruped. Built for heavy-duty industrial deployment, it can carry payloads of up to 30 kilograms for up to 90 minutes while navigating stairs, rubble, confined indoor spaces, and uneven outdoor terrain. Equipped with LiDAR, high-definition cameras, and optional thermal and acoustic sensors, it can autonomously patrol facilities, scan for overheating components, detect abnormal machinery sounds, read gauges, and identify leaks. At logistics hubs, it conducts 24/7 security rounds, inventory scans, and perimeter inspections. These systems reorganize human expertise. A single technician can oversee an entire fleet, intervening only when the robots flag anomalies requiring judgment or repair. While quadrupeds address industrial inspection, a parallel track focuses on humanoid robots designed for human-centric environments. Demographics drive this development. Citizens age 65 and older now account for roughly 15% of the population, and China is projected to become a super-age society by 2035. The gap between caregiving demand and available human labor is widening rapidly. Companies such as UB and Fourier Intelligence are developing humanoids for this silver economy. Platforms like Fourier's GR1, a 5'4" humanoid with vision, audio, and tactile sensing, perform physically demanding tasks such as lifting and supporting patients. At the same time, firms like Agibot and UBTech are targeting customer service and flexible manufacturing, where adaptability is as important as strength. The humanoid form is functional, not aesthetic. Homes, hospitals, offices, and factories are built for human movement, reach, and manipulation. Doors, stairs, tools, and workstations all assume a human body plan. Robots with similar morphology can operate in these environments without costly retrofits. Agibot aims for a sub-$20,000 price point to make humanoids accessible to small businesses. UBTech's Walker S is already deployed in factories and retail spaces, performing inspection, concierge, and service tasks in real-world conditions. However, a fundamental limitation remains. Robots with rigid, mechanically simple bodies must rely on massive computation to compensate. The Tesla's Optimus consumes roughly 500 watts while walking, compared to 310 watts for a human. Every minor movement requires continuous visual analysis and motion planning, making humanoids slow, energy-intensive, and fragile in unpredictable environments. The next breakthrough may not come from AI alone, but from mechanical intelligence. Passive, adaptable design, compliant joints, tendon-like energy storage, tactile skin, and feet that conform to uneven ground reduce computational load. Robots with embodied intelligence can focus AI resources on high-level reasoning, turning impressive demos into dependable daily workers. As these technologies approach deployment, China is also addressing social acceptance. The AI Shopping Mall, or Robot Mall, opened on August 8, 2025, in Beijing's E-Town district, as the world's first 4S retail hub for humanoid and service robots. Modeled on the automotive concept of sales, service, spare parts, and surveys, it offers a complete lifecycle experience, from selection and purchase to maintenance, upgrades, and user feedback. Housing more than 50 brands and over 100 robot models, the mall showcases industrial arms, logistics robots, entertainment bots, and humanoids like Tian Kung and Walker S. Visitors interact with robots in real time, watching them serve coffee, play chess, patrol floors, and perform other tasks. The mall's location is strategic. E-Town is a key node in China's robotics supply chain, with an industrial output exceeding 10 billion yuan. The robot mall functions as a public-facing interface, allowing factory managers, logistics operators, hospital administrators, and property managers to test and adopt automation solutions. For small enterprises struggling with labor shortages, it provides a tangible path to robotic integration. Adjacent to the mall, a robot-themed restaurant deepens the immersive experience. Humanoid bartenders greet visitors amid holograms and dynamic lighting, while a live robot rock band performs. Service robots navigate the floor, dinosaur-like companions entertain, and animatronic figures modeled on historical icons, poets Sushi and Li Bai, or a robotic Isaac Newton, interact with guests. As humanoids walk among us, performing tasks once reserved for humans, will there still be a place for human hands or minds in this new world? Thanks for watching. Now check out the videos popping up on screen for more unbelievable stories.